Hey class, today is solving absolute value equations, lessons 1.4. We're going to keep this moving, so if you need to pause and replay something, feel free to do that. Again, we're going to start with this opener. You're going to spot the error and fix it. That's what we're doing as a class opener. So you want to make sure there's at least 3 different errors in this, so you want to make sure that you can find all 3 of those and then fix them and solve this one correctly. Sometimes it's helpful just to start from the top and redo the problem your own without looking at this work. Alright, so today's learning target is I can solve absolute value equations. Just remember an absolute value sign is something like this, where you have the 2 straight bars outside of a number. So let's say we have the absolute value of x is 2. This would then mean that we could have x is equal to 2 or negative 2, because absolute values are the positive form of that number or of the thing they're looking at. So you can plug in both 2 or negative 2 in. If you run them through an absolute value function, it will turn it into a positive. So using that idea here, this is how we would change this. We read this as the absolute value of x minus 4 is equal to the value 6. So we would split this into 2 different equations. So we would have x minus 4 equals 6, and we would also have x minus 4 is equal to negative 6. Okay? Should be a minus sign between there. Alright, so then we just solve for x in both cases. The one on the left, we'd add 4 to both sides, and we get x is equal to 10, and then one on the right, we would get x on both sides, and we would get x is equal to negative 2. So our 2 solutions here are x equals negative 10 or x equals 2. Notice when I got rid of my absolute value signs, I only changed the number on the right. I didn't change the stuff inside the absolute value. Alright, here's our next one. So our next one has a little more going on. You can see it has an absolute value sign with properties inside of it. It also has an additional minus here, equaling a number. So instead of getting rid of the absolute value first, we want to get this by itself. So the first thing we're going to do is we're going to add the 10 over. So then this would become absolute value of 3x plus 9 is equal to positive 6. Now we take the positive and negative forms of 6. So we'd have 3x plus 9 equals 6, and 3x plus 9 equals negative 6. At this point, we would simply solve out each equation. So the one on the left, the first thing that I'm going to do, I can see they're all divisible by 3 here. So I'm going to divide it all by 3 first. So if I go divide by 3, divide by 3, divide by 3, I'd be left with x plus 3 is equal to 2. If I subtract the 3 from both sides, I would have x is equal to 1. In case you don't like that divided by 3, I'll do it the other way. For this one, if I want to get rid of the 9 first, I could subtract 9. So I'd have 3x is equal to negative 15. Divide both sides by 3, and I would be left with x is equal to negative 5. So just 2 different ways to solve. Notice how this one, because they are all divisible by 3, I divide them all by 3 first. I could have done that here, but I want to make sure I'm showing you guys different ways of solving. So this one I just did the classical subtract the 9 first and then divide by 3. Alright, so sometimes you're going to be given word problems, and when you're doing a word problem and you're writing one out, it's important that you are considering what is the question asking. So this one says, in a cheerleading competition, the minimum length is 4 minutes, and the max length is 5 minutes. We want to write an absolute value that represents the minimum and the max lengths. So we're saying we want all the values between 4 and 5. So if we think about this on a number line, we know our smallest one we can have is 4. We know our biggest one we can have is 5. Right in the middle of 4 and 5 is 4.5, meaning that the space in between that middle point and each of the ends is 1/2. So we would write this equation as the absolute value of x minus 4.5 is equal to 0.5. So for any value that this is true for, it would work to be that long of a program. Alright, we're going to continue to move forward. Again, up to this point, we've only looked at where the absolute value is only on the left side. Now we're going to be looking at where there are two absolute values, one on the left and one on the right. This rule here sums it up pretty well. If there's an absolute value on the left and there's one on the right, you still keep everything on the same on the inside for the left one, and you first have the positive form of everything on the right, and then you still have the negative form of everything on the right. So let me show you how that one looks here. When we break this apart, we're still going to have 3x minus 4 is equal to the value of x, and 3x minus 4 is equal to the value of negative x, because again, this x was everything inside this one, just like how everything inside here went positive and negative, in the sense of in front of it was a positive or negative. So now that we have these, we just solve like normal. I can add 4 to the other side, so I'd have 3x equals x plus 4, subtract the x, so I'd be left with 2x equals 4, so x is going to be equal to 2. Then my other one here, I would add 4 as well, and I would add the x over, so I'd be left with 4x equals 4. And again, that's just from going plus 4 this way, plus x this way. And then I divide both sides by 4, so I get x is equal to 1. Alright, so up to this point, every example we've looked at works out. It checks out if we plug answers in. But now we're going to show you an example where sometimes the answers you get do not actually work, which is why you need to check your answer on every single problem. So this example here has the absolute value of 2x plus 12 is equal to the value of 4x. So as we've seen, if you have absolute values, you keep the inside of the absolute value the same, and whatever it's equal to, you have both the positive form of the whole thing and the negative form of the whole thing. From there, you'd solve them out like normal. So in this case, the first thing they did was they subtracted 2x over to get 2x on the right. Then they divided by 2 to get x equals 6. This other problem, they did a similar thing. They subtracted 2x over, so now instead of having negative 4x, they now have negative 6x. Divide both sides by negative 6, and they get negative 2 is equal to x. So these are our two answers. However, over here, when you're checking your work, you'll notice that when you plug in the 6, so when you plug in this first answer, it does solve out correctly. It gets to 24 equals 24. However, when you plug in the second answer of negative 2, we answer these ones out, so we'd have 2 times negative 2 is negative 4, plus 12 is 8. 4 times negative 2 is negative 8. 8 does not equal negative 8. That is not the right equation. That does not work, because no absolute values can be negative, for one, but also just the fact that 8 doesn't equal negative 8. So here we would accept this, and we'd reject this. This is an example where mathematically you can find multiple right answers, but that's why you always want to double check your work. Alright, so we're going to use that idea to solve this one. So here we would have x plus 5 is equal to x plus 11, and we would have x plus 5 is equal to negative x plus 11. So as we solve these ones through, here you would get, on the left one, add 6, subtract x, so you'd have x equals x plus 6, because we're subtracting that 5 over, and then we subtract the x, so we have 0 equals 6. Well, right away, that one's not true, so we know that this answer over here doesn't have a solution. So now as we look at the second piece over here, we're going to simplify this. The first thing I'm doing is I'm going to distribute like normal. So I really have x plus 5 is equal to negative x minus 11. And now as I work this one around, I would get 2x on the left by adding the x over. I'd subtract. So I added the x over, so I got 2 x's on the left. Subtract the 5. So I'd have negative 16. So then my answer here is x equals negative 8. So again, this one over on the left is a reject because that one doesn't work. But the one on the right would work. So it is possible sometimes when you're finding answers that you have two answers or one answer or maybe even no answers. So your homework for today is 33 problems. It is numbers 1, 2, 4 through 44 even, 45 through 50, 60, and 62 through 67. Probably 20 to 30 minutes to finish this. Remember, tomorrow you have your 1.1 to 1.3 quiz. So absolute value is not on there, but everything from 1.1 through 1.3 is. Good luck.